Hello all and welcome to part 2 of using first principles with fractional functions. So from our last video I'll just recap what we did. As you can see I have jumped ahead a little bit, but don't worry, I'll go through and explain what I did. But from our last video we wanted to work out how to use first derivatives to find the tangent of a slope at x equals 5 for the function 4x plus 1 divided by x plus 2. And our expected answer based on that was -1. So now, I introduced you to the first principles equation. The limit as h goes to 0 is the f of x plus h take the f of x all divided by h. And what I've just done with the first step here, and let me talk you through what I've kind of done by jumping ahead. I just want to go through it again to make sure I didn't make an algebra mistake live on camera, because that would be very embarrassing. But let's see what I've done. So we have 4x plus 1, and what I've done is wherever there's an x for the first bit, I've just put x plus h there to make it nice and simple. So in the bottom we had x take 2, so it's now x plus h take 2. And then we subtract that from the function just as it is, so I just threw that from there to there, just copied it straight across, so that's all fine. So now, what I did, and I want to do this early, and I recommend that you do this early before things get too complicated, is you want to get rid of the brackets. Now, remember you don't here, and this is very important, with these brackets here, they're not multiplied by -2. It's always take 2. The reason I put brackets around it here was just to show you what I was doing in the video before. However, there are technically brackets around that because we both needed times them both by 4. But there's no brackets here. That's x plus h take 2 all as one term. And that's worth noting. The only time where you actually multiply one of these x plus h brackets by another term is if in the original equation, like it is here, there's a coefficient and then x. Because of course that's a new x, so it needs to be times by the coefficient. But in here, where there's a take, and it's not a multiply, it's not 2x, we need to make sure that we do not get that mixed up so it doesn't become -2x take 2h, because then we'd have a massive, massive problem. I'll just stress that there. But what I've done is again use Distributor Floor just to be able to expand those brackets, and we get 4x plus 4h. Again, 4 times x, 4 times h, plus 1. And the bottom line, just remove the brackets from the x plus h, because again, remember, do not multiply. And then we just subtract the original function. So that's all fine and dandy there. Now, you're probably looking at this line and you're thinking like, how did he get to there? We have a multi-layered fraction here with 3 parts that look scary and confusing. How did he get to this next bit there? And the answer is, well, I cross-multiplied and found a common denominator. But much more simply, let me direct your attention to here. So this is what we have. We have A, B, C, D, H. Just a rough translation. So numerator of the first part is A, denominator of the first part is B, that's C, that's D, and we're all over H, right? Just giving it sort of a nickname. Now you may remember cross-multiplying, probably done it in grade 9, 10. What we do is we simply take this here, B term, and we multiply it by C up there. So we're getting rid of this, and we do the same for the other side. We get that D term, and we make it A. So again, we just bring them up, so D goes to A, and B goes to C. Cross-multiplying, that goes there, and that goes there, and we're going to times the two things together. And there's going to be a subtract sign in between. So we're going to have dA, da, take BC. And then, that's all fine. I hope you're sort of following the cross-multiplying thing. Again, it's quite a simple process, but we're all going to have that over H. And then we're just going to have it over the original denominator. So it will be H, lots of that, times that. H, B, D. If you remember this, then you'll be fine with fractional first principles. You just need to remember that. The hardest part after that is avoiding making an algebraic mistake, which I think I didn't do. So, wow, we're off to a good start. But remember that. That's important. This corner of the board. Look at it. Remember it. Love it. So now what we do, Distributor Floor again. And it's going to get quite big, quite significant like this, because that is what it's going to be. we have x times by 4x, 4x squared, x times by 4h, 4hx. Then we have x times by 1, x. Then we have negative 2 times by 4x, negative 8x. Then we have negative 2 times by 4h, which is going to make negative 8h. Then negative 2 times by 1, negative 2. We're going to have a subtract in between. Don't forget about that. Then we're going to expand. So we're going to have x times 4x, which is going to be 4x squared. Then we're going to have x times by 1, which is going to be x. Then we're going to have h times by 4x, which is going to be 4xh or 4hx, depending on whatever way you want to do it. Then we're going to have h just by itself, because 1 times h is h. Then we're going to have negative 2 times by 4x, which is going to be 8x. And then we're going to have negative 2 times by 1, which is going to be negative 2. And that is what we get. We get 4x squared plus 4hx plus x. Take 8x, take 8h, take 2, and then subtract. And then all of these terms, we're going to change the actual signs because there is a take out the front, a subtract symbol. So let's actually do that now quickly. So if we have a subtract here, and we want to get rid of the brackets, we're going to have to change all of the signs. So a positive and a negative make a negative. So by positive sign into negative sign. Same thing here. And then same thing here as well. And then these two are going to become positive because they were negative, negative, and two negatives make a positive. And again, we have that all over h, b, d. And we're keeping h separate. We want to keep h separate because it's very important for when we want to cancel later on. But that's the second part of the video. I know I said it would be 2 parts, but it looks as though it's going to have to be 3. So you're welcome to come back for the third part, and we'll finish this off once and for all. But again, remember, take it slow, remember this, and try to avoid making a simple algebraic mistake. Remember, use the first video tool, the first thing we ever did, the quotient rule, to be able to check that you're getting the right answer. We'll get to the right answer using first principles in the next video. Thank you.